Okay, we're good to go. Sorry about that. So anyway, I'll start with some motivation about what recent natural language understanding has given opportunities for new applications. But also, I'd like to point out this kind of task, for instance, topic recognition, which, if you want to do it right and have some meaningful applications, you need to have models that are able to model long word sequences. So, for instance, if we have emails and we want to do mail optimization, we're going to deal with variable length text and most likely with long text as well. So there are exciting tasks. Another exciting task is the question answering. So here, for instance, again, if we condition a question on a Wikipedia webpage, for instance, and we want to ask what is the masterpiece of Gaudi, for instance, we'll like to get an answer like Sagrada Familia. So that's an exciting application for having a navigation system or to do interactive search. But still here is another essential component, as before, is to be able to understand long word sequences. More recently, another exciting application that have really advanced quite a lot in NLP recently is machine translation. Here as well, currently it's at the sentence level, but if we really want to make accurate translations, we need to go beyond that. So I argue here that the fundamental function across all these language understanding tasks is to represent meaningfully long word sequences. So recently this has boiled down to be learning representations of word sequences, which encode the meaning or the knowledge that is needed to solve the task, right? So in this talk I'm going to be focusing on topic recognition. But the main question that I pose here is whether we can benefit from having multiple languages, so when solving the task in multiple languages. And I will try to convince you that you can not only benefit from it, but you can also do it more efficiently. So I'll try to show you some limitations that we faced in the beginning when we tried to solve this issue. So current approaches that has been a lot of work on monolingual text classification. There have been many advances, like from having convolutional networks and hierarchical networks that work very well for one language. However, when you have multiple languages, you have a large number of languages, you have some issues. For instance, you need to train separate models, so that increases the computational cost that you need in order to obtain these classifiers, for instance. And also, you have knowledge that exists in several languages that you may reuse in another language, but this possibility it's not present in this kind of works. So one way to tackle this is, okay, we said we'll try to see what people have done in multilingual, multilingual methods, for instance. Multilingual methods are when we try to learn word embeddings for multiple languages that share a common space. And so words that share similar meanings in different languages are going to be embedded in a similar position in the space. So one idea is to use this language-independent feature space, so you can do learning from all the languages, and then, okay, you have constant number of parameters as the number of languages increases. However, existing works in this area are required to have common label sets across languages. So you need to have this constraint that, okay, I have 10 categories in English, and I force myself to all other languages need to map there. This is something that is not desirable, and in a real-world application that we faced in the Suno project, that was really an issue. Also, most of the works on multilingual methods focus on more shallow learning, so I think previous talks mentioned briefly about that. But here we would like to be able to have some more sophisticated modeling of the document, and so here in this talk we'll try to combine both worlds, and in a sense We want to have language-independent learning. We want to have a sublinear growth in parameters as the number of languages increases. And also we want to be able to have arbitrary label sets across languages when we train. And finally, we'd like to use a state-of-the-art document model which has a hierarchical structure that is learned across all languages. So a little bit of background. Sorry. So a little bit of background. So our work is based on these hierarchical attention networks. So in a sense, they call the hierarchical. So the input that they take is a sequence of word vectors, and the output is, well, a representation for our document. So it's called hierarchical because it has this structure over here, which is hierarchical. In a sense, we have word level and sentence level abstractions, which have two important components. One is the encoder component, which tries to learn features related to that level, and also the attention mechanism, which learns to focus on important parts of the input in order to compose a representation for the long word sequence. So after having composed the representation for the document, then depending on the task at hand, we can have a classification layer, for instance, for topic recognition, or other kind of layers for other tasks. Here we focus on classification. So the training is done with stochastic gradient descent end-to-end. And for the word embeddings, you can use pre-trained ones, or you just fine-tune them on the end task. In our case, we use pre-trained ones. So, well, what we propose here is to take this idea and, of having a single model to, a language-specific model, and being able to learn a document model which have shared structures across languages. So we do this by proposing these three distinct ways. So we have this hierarchical network, and which is trained in a multitask fashion on these arbitrary label sets. But what we do is essentially we either share the encoders, so the features that are learned at every level, or we share the attention so the attention at each level as well. So it's shared across all languages. So the final idea is to use one network to share all the parameters and again train on all the languages. We compare them later, and we see that this architecture may seem straightforward, but it does not perform the best. So I'll show examples later. So the good thing with this kind of modeling is that we save some computational cost. So in a sense, when we start sharing parameters, the multilingual models that we build, in total, they're going to have much fewer number of parameters, but still they will have the same result. Just to show you here an example of performance on real-world data from the SUMA project. So here we have general and specific topics for 8 languages. On this column, I show the average performance over all languages as a F1 score. And here I show the average number of parameters per language that are needed. So you can see that as the number of languages increases, the number of needed parameters, the average needed parameters per language decrease, but also the performance increases. So that's quite interesting. Just to note here that if you use a naive deep learning multilingual adaptation, it fails a lot. So, for instance, if you don't have an aligned space as input, and you say, okay, deep learning can learn anything, you just fail in, leveraging all the information from all the different languages. So, well, we have here's the training strategy. Essentially, we minimize the sum of cross-entropy errors. And so, again, if you have a naive consecutive training, one language after the other, this does not end up with a good model. So it essentially biases the model towards one language, and then when you come to the second language, you forgot what you learned before. So what we propose here is to sample document label pairs for each language in a cyclic fashion. This allows at each iteration to be able to learn from all the languages at the same time. And again, the optimization is done with the same way as before. So this is a data set from the Suma project. So we have 600,000 documents in 8 languages, which have topics assigned from journalists from Deutsche Welle. And so the goal is to be able to train these jointly and show what's the benefits of the method that we propose. So here I show a full research scenario. So essentially we show an example of bilingual training. So we compare methods that do multilingual training versus the ones that do monolingual. Note that these ones are the methods that I showed in the beginning that have these limitations. And here are the results for the general topics, and here are for the specific topics. So overall, we can see that consistently the multilingual models outperform the monolingual ones. So, and also that the best configuration in this multilingual architecture is to share the attention across all languages. So that's quite interesting because you have the same mechanism which decides what parts of the text are important across all languages, and this really leads to significant improvements. And for the ones that, question whether deep learning may not be as good as some traditional methods, we also, for sanity check, we have done comparisons, and here I show an example for English and Arabic when we compare with baseline logistic regression with bag of words. So essentially, the neural model it has the edge, clearly. And also this has been shown in previous recent studies in neural text classification. So moving on to the low resource scenario. In this case, again, we train languages on pairs together, but this time we try to limit or vary the number of training examples for the target language. So here is the performance of the monolingual model for this task, and here we see what happens when we train with multilingual one, and we see that really in all cases we can benefit from multilingual training. And it's quite interesting that in the low resource case, the less data you have, we see the higher improvement you get from the multilingual training. So that's quite an interesting finding. And also we can see that in the plot over here. So finally, some qualitative analysis. Here I show a graph which on the y-axis shows the cumulative true positive difference between the multilingual and monolingual model. So what we can see here is that the true positive difference increases over the entire spectrum. On the y-axis we have, on the x-axis we have the topics ordered by label frequency. So we see that overall the entire spectrum, we get the true positive difference increases in favor of the multilingual model. So it's interesting because you get to really improve even topics that are rare enough. So, well, here I show some examples of topics that have been improved for this English-German pair. What improved for the German when trained with English. So it seems that keywords like Rusland, Iraq, and NATO got boosted. And for English, when trained with Germany, apparently Germany and German, soccer, football, Merkel got more well recognized. So, okay, that's just the same check to see what's going on. And and finally, something that I'd like to show here is interesting is it's also you can well, in codes, you can think of the output of such networks to be sort of interpretable, because you can, well, look at the attention scores and see what parts of, the text are important for making the labeling decisions, which, may be useful for some applications as well, and also for understanding what's going on. So, okay, so yeah, we propose this new multilingual model to learn shared document structures for text classification. Well, we show that it can benefit both full resource and low resource languages, and we can have better accuracy with fewer parameters. So this demonstrates that the benefit of the cross-language transfer for topic recognition, but this may be the case also for the other NLU tasks. So as future work, we'd like to remove the constraints of having closed label sets and also to incorporate label information in the classification. So thank you for your attention. And also, before that, I'd like to advertise this. The Suma project has a user group meeting in Caversham with plenty of talks and discussions. So feel free to contact us if you are interested. Thank you.
Do you have time for a few questions? Any questions? Yep.
Yes.
And for the cross-language transfer, how important is the similarity between languages? Do you see stark difference between German English, including German Arabic?
So, yeah, I think I understand the question. So, we didn't really observe, well, we tried to see whether there's a correlation, when languages are related, they are Germanic languages or they are Roman-based languages, to see whether, all of them improve together in some certain conditions or not. But unfortunately, we haven't seen a strong correlation on that. And, well, we attribute that possibly to, the journalists that fill in the topics, they have their own way, their own language to describe things in news. So it's not clear that we have to figure out, to really isolate only the language component, which was difficult to do. So. Any other questions?
Okay, awesome. Yeah.
So yeah, if you follow up, it's gonna be soon. So if you follow up our website, we'll share also the code and the paper. So.
Any more questions? No? So good, then let's thank the speaker again.